Okay, this is number 4 in the free response questions in the AP Precalculus sample questions given by the College Board. Okay, this is the last problem in the sample question set. All right, so this is all this jargon I'm not going to read, so let's jump in the questions already. You can read that yourself. Functions f and g are given by these. So the first one, we write g of x as a single natural log without negative exponents in any part of the expression. The result should be of the form ln of something. Okay, so wrote it over here. We want to write this as a single log. How do we do that? Well, we have 3 log x minus half log x. So we can already reduce that to be, this is the same thing as, we even write it like this. 6 over 2 log x minus half log x, which we can combine as 5 over 2 log x, correct? And then we want it as log of something, so we can pull this coefficient out in front, back inside the log. So it would be log of x to the 5 over 2 power. Okay, this is your final answer. You can even write the domain, x has to be greater than 0. Okay, so I would write that. This is what the scoring guidelines also put, so I would just put that also. Okay, and then next, we write h of x as an expression in which cosine appears once and no other trig functions are involved. Okay, so how can we do that over here? Well, I can rewrite this as negative of 1 minus sine squared. Okay, this should look familiar. This is now looking like the Pythagorean identity. 1 minus sine squared is cosine squared. So it'll be negative cosine squared over cosine x. We can reduce that to negative cosine x. And we have to write that cosine x cannot equal to 0. This is part of the domain. Okay, so this is more critical than over here, in my opinion, but you should write this. This is also in the scoring guidelines. So our final answer is negative cosine x, where cosine x cannot equal to 0. Okay? So everyone like this. Where x is greater than 0, where cosine x not equal to 0. Okay? I will write it like that. Okay. Functions j and k are given by these. We want to solve g of x is equal to 0 for x in this interval. Okay? So this is basically solving a trig function. Okay, so j of x, I set it equal to 0. So how can we solve for this? Well, we can factor out a cosine from both terms. So it would become cosine of x times 2 sine of x minus 1. Okay? Is equal to 0. So we have 2 branches where this can happen. So cosine x is equal to 0, and 2 sine x minus 1 is equal to 0. So this one, within this interval, x is equal to pi over 2, right? Cosine of pi over 2 is 0 within this interval, right? This one, we can even write as sine x equal to half. So x is equal to what? Where is sine equal to half? That's equal when x is pi over 6, right? Within this interval. So the answer is, maybe right here, x is pi over 2, or x is pi over 6. Okay. And then the other one, we had to solve 8e to 3x minus e is equal to 3e. How do we solve this? We can move this e to this side, so 8e to the 3x is equal to 4e. Okay, so we can divide by 8 on both sides. So e to the 3x is equal to e over 2. Now we log both sides, so 3x is log of e over 2. X is log of e over 2 over 3. We can actually simplify this using properties of logs. It'll be ln of e minus ln of 2 over 3. ln of e is just 1, so it's 1 minus ln 2 over 3. That's how I would solve that. Okay. And the last one, m of x is cosine 2x plus 4. Find all input values in the domain of m that yield an output value of 9 over 2. So we want to set this equal to 9 over 2, which is why I did it over here. Okay, so remember this can happen an infinite number of times. So we want the general solution. That's why it says find all input values in the domain of m. Okay, so remember how we find a general solution? Okay, so let's solve for x first. So for cosine 2x is equal to 9 over 2 minus 4. That's equal to half. Okay, so when does this happen? Well, when 2x is equal to, so let me write it on the side. When we have cosine of like u is equal to half, that's when u is, that's pi over 3, right? Plus 2 pi n, or u is negative pi over 3 plus 2 pi n. Okay, so when it's just u, but we have 2x, so 2x would be pi over 3 plus 2 pi n, and it's an integer by the way, or 2x is negative pi over 3 plus 2 pi n. And then we solve for x here, so x is equal to pi over 6 plus pi n, or x is equal to negative pi over 6 plus pi n. N is an integer. So I would solve it like this. Okay, and actually if you look in the scoring guidelines, they put 5 pi over 6 instead of negative pi over 6. So let me write it maybe in a different color. They put x is 5 pi over 6 plus pi n, which is the same thing as here. So this should be fine, but they put it like this. In my head, it's easy to think of it as negative pi over 6. But when we plug in n is negative 1, we get negative pi over 6. This is the same thing as if I plug in n is 0 over here. So it's the same answer, right? But just starting from a different point. And yeah, okay, so this should be fine also. Okay, so that's it for the free response in the sample questions. Hopefully this was helpful. Please like this video if it was, and please subscribe also to the channel if you haven't already.